Welcome back to the Mod 4 Part 4 notes. These are pages 2 and 3. 2 has a lot of information on it. Again, I am not going to read it to you, but we are going to discuss what is called a box and whisker plot. A box and whisker plot is great for visualizing the physical spread of the data. Okay? So think about how we divided this up before. Our median cut our data set in half, 50% above, 50% below. Q1 cut that bottom half in half. So as we look at this, we know that 25% of the data values lie in that bottom whisker, 25% lie in the bottom half of the box, 25% lie in the top half, and 25% lie in that top whisker. If I had 40 values in my data set, each of those whiskers would contain 10 values. And so the length or the compactness of each part visually shows us how spread out or how close together the data is. Okay. There's always the chance, as we've seen in the past, that we've got extreme observations. Those values that lie way outside what we consider the norm, these are called our outliers. And this page gives you directions for how to find the outliers. Now, in example 1 on page 3, I will compute that lower fence and upper fence. You need to know how to do that. When we go to example 4 and do this in Excel, Excel will create the box plots with the fences in, but we won't actually see the fence, okay? So our lower fence here, means we take our interquartile range and we go 1.5 times that below Q1, okay? So just a reminder, here's our interquartile range. 1 times the interquartile range gives us that whole box, okay? If we were to multiply 1 times that interquartile range and subtract it from Q1, I mean, we're down here. By going 1.5 times, here's where our lower fence goes. We are extending out and saying, hey, anything below that lower fence we feel is not consistent with the other values that we have. We find the upper fence roughly the same way, except this time we are adding that to our upper quartile. So this was -1 times the interquartile range. This is going to be +1 times the interquartile range. So roughly 1.5 times puts us up here, okay? So once I find my 5-number summary, I am going to go ahead and calculate those fences. I am going to sketch those in before I draw my box plot. Feel free to pause right here so you can read through these directions. I'm going to walk through this on the next page. So example 3. From example 1, I know I have a minimum of 50, Q1 of 72, my median is 75, Q3 is 81, and my maximum is 92. First thing I'm going to do here is find my interquartile range. So remember that my inner quartile range is Q3 minus Q1. My Q3 is 81. My Q1 is 72. When I subtract those, I get 9. Okay. To find my lower fence, and I'm going to write the equation just as it is above, Q1 minus 1.5 times my inner quartile range. My Q1 is 72. 1.5 times 9 gives me a 13.5. Right, I'm going to use the same inner quartile range that I got right here. Not going to highlight it so you can't see it. When I subtract those, I get 68.5. To find my upper fence, I'm going to go ahead and add that 1.5 times the inner quartile range to my Q3, 81, plus that 13.5, and I get 94.5. These are my fences. Okay. Let's go ahead and draw the box plot. I want to start by creating a number line that is evenly spaced. I am not just going to list my 5-number summary evenly spread out because these numbers are not evenly spread out. So I'm going to start here with 50, 60, and if I'm handwriting it, I'm going to do my best to evenly space these. I am going to make note of where my lower fence and my upper fence is. So I've got a lower fence of 68.5. I don't know why that keeps coming up. So here's my lower fence. I have an upper fence of 94.5. These are just general. I'm going to go ahead and highlight these the same as above. Hopefully, if you're looking at just a copy of the notes online, that makes sense. And now I'm going to go ahead and put in my 5-number summary. So I've got a minimum here at 50. And already I see a problem. That minimum lies outside my lower fence. We're going to talk about that in a minute. I have a Q1 of 72, a median of 75, a Q3 of 81, and a max of 92. This one lies in my upper fence. That one's okay. Okay. As I draw the box and whisker, I box in with those middle 3 values, and I extend a whisker out to my max and min, provided it does not cross a fence. So here I have a problem. My 50 at that low end is an outlier. It lies outside that 1.5 times the inner quartile range. I'm going to mark that with an asterisk. I'm going to go up to my data set, and I am going to look for the next smallest number. My next smallest number is 68. And look at something here. My lower fence is 68.5, which means that this 68 is also actually an outlier. I'm going to mark anything that falls outside. Okay, so back up to my data set. Next smallest value is that 72, which happens to be the same as my Q1. And so this is what this box plot looks like. I don't have a whisker that goes out towards the minimum on this side because that extends past my lower fence. Okay. Keep in mind, each chunk here contains 25% of my data. So I can see that between Q1 and that median, that data is really close together, more spread out as it goes above. Let's take a look at example 4. Remember, example 4 had that larger number set. So I already said I was not going to do that by hand. What I am going to do, though, is calculate the fences again. So I had a min here of 1. Our Q1 was 7. Our median was 18. Our Q3 was 27. And our max was 94. My interquartile range, which is Q3 minus Q1, which is our 27 minus 7 here, means our middle 50% of the data is only 20 values apart. Okay. To find my lower fence, I'm going Q1 minus 1.5 times my interquartile range, and I have a little more room, so I'm going to write that out here. My Q1 is 7 minus 1.5. That interquartile range was 20. I got 7 minus 1.5 times 20 is 30. Gives me a negative 23. As odd as it may seem, it's okay to have a fence that is a negative value. So my lower fence is down here somewhere. My upper fence, Q3 plus. Since we already know that 1.5 times 20 is 30, let's see, my Q3 is 27 plus 30. I get an upper fence of 57. So here's my upper fence. Okay. Notice that that lone value of 94 lies above the upper fence. Let's go back up here. We don't have anything between this 33 and this 94. So I have that one low value up there, lone value. Sorry, here's our 94. Notice this time, though, that the 33, that is the next highest value, has now become the end of that upper whisker. Okay. And there is the box plot for example 4.